know that. Then the biodegradable. When we talk about biodegradable, those are the ones that can be broken into harmless substances. In the environment we have those substances that are biodegradable and those that are what? Non-biodegradable. Those that are non-biodegradable, they eventually turn into what? Pollution, because of the fact that they cannot be broken into what? Harmless substances. Then, assess the effect of pollution on the environment. The effect of pollution on the environment is so devastating that it has, over the years, led to the loss of lives because of the fact that, like, let's see carbon monoxide as an example. It's combined with the hemoglobin in the blood system, thereby cutting off the oxygen supply. So, and in no distant time, the person dies. Also, we have some of them that leads to what? Acid rains. Then the chlorofluorocarbons, the CFCs, that causes chlorofluorocarbons, the CFCs, that causes cataracts, and also the chlorofluorocarbons also cause the sunburn, because it has a way of depleting the ozone, and when it depletes the ozone, there is the ultraviolet radiation are being exposed to the earth, and on that verge we have the lead to cancer, the skin cancer or the sunburn. So these are the various harmful effects of pollutants. So this will not be treated as a separate topic, because the questions that are designed we have treated in the topic A. So let's move to the next topic, which is acids, bases, and salts. Under the acid, bases, and salts, the objectives should be our interests. Under the objective, we have candidates should be able to distinguish between properties of acids and bases. So we have properties of acids and base properties. So if you talk about properties of acids and bases, then we'll be talking about, we have the physical properties and we have the chemical properties. Physical and chemical properties. In the case of physical properties, we know that acids are corrosive. We also know that acid turns blue litmus paper red. And we also know that acids have sour taste. So these are the physical properties. Then when we talk about chemical properties, which we have treated in our previous lessons, even in the colleges, we know that chemical properties, acid reacts with metals to liberate hydrogen gas, it's one of them. Acid reacts with base to form salt and water, that is neutralization reaction. Then acid reacts with triazocarbonate form to liberate carbon dioxide. I think these are the notable chemical properties of acid. Then we talk about base. Base turns red this time around. Red litmus paper blue. Base is soapy to the touch, and the concentrated form also are very corrosive. Base, in terms of chemical properties, they react with acid to form salt and water, that is neutralization reaction. And they also react with ammonium salt to liberate ammonia. That should be noted. So these are the notable properties, both physical and chemical, as far as a base is concerned. Then also, the different types of acids and bases. We know we can classify acid into what? Strong acid and weak acid. We can classify into strong acid and weak acid. What is referred to as a strong acid? Acid is said to be strong when it ionizes completely in solution. Then it's said to be weak when it's ionized partially in solution. Example of strong acid, we have H2SO4, which is tetrasulfate 6 acid. We also have HNO3, that is triazonitrate acid. We also have HCl, that is hydrochloric acid. Then in the case of the weak acid that we have H3PO4. We have H3PO4. We also have our acetic acid, that's ethanoic acid. is a very weak acid, and what have you. Then the bases also follow the same category. We have the strength. The strength of a base is the ability to ionize in solution. So also we have differentiate between acidity and alkalinity using acid-base indicators. How can we differentiate between acid and base using acidity and alkalinity of the content? So in this situation, to use an indicator, we have different kind of indicator. We have phenolphthalein, we have methyl orange, we have litmus paper itself, and so on and so forth. So acid and base have different or specific color when in contact with these indicators. Like in the case of acid, then we have base. In litmus paper, it is in acid, it changes from blue to red. So it becomes red in acid, while in base it becomes blue. Phenolphthalein, it is colorless in acid, while methyl orange, it is red, and sometimes some people say pink, it can be red. Then you have orange, while the phenolphthalein in this is purple. So in this situation, these are the respective color change as far as all these are concerned. So we can use acid base with respect to the indicators. So when you see a particular color, then you can say really that okay, this must be a methyl orange, and this must be. And these are the trends that you have as far as acid-based indicators are concerned. Then identify the various methods of preparation of salts. We can prepare salts by diverse methods. We can prepare it by direct combination. We can prepare it by reaction of acid with insoluble base. When you react acid with insoluble base, then you have something like this, H2O. Then another fundamental way by which is very notable is preparation of insoluble salt, and that can be prepared by double decomposition. You can prepare that by double decomposition. Also, in the case of direct combination, salt can be prepared by direct combination. Then we have sodium chloride, which is a normal salt. Classify different types of salt. We know we have different types of salt. We have the normal salt. We have the acidic salt. We have the basic salt. We have the double salt. And we have complex salt. So in the case of this, because salt is a compound form when part or all the ionizable hydrogen ion in an acid is completely replaced by a metal or ammonium ion. So if you talk about normal salt, that means that all the ionizable hydrogen ions are completely replaced. So example of that is sodium chloride, calcium chloride, and what have you. Then in the case of acidic salt, they are partially replaced. You will see in the presence of hydrogen ion. So in that situation, I can have sodium hydrogen sulfate, potassium hydrogen sulfate. These are examples of what? Acidic salt. We are talking about basic salt. That one contains an element of OH. The OH, the acid, the hydrogen ions is unable to neutralize all the what? OH, the hydroxyl ion. So in that situation, we will have this. Is an example of a basic salt. Then we'll talk about double salt. In the case of double salt, something is evident. You have M+, that's a metal, and you have M3+. You have M+, M3+, SO4, subscript 2.12H2O. So in this situation, if I pick potassium, aluminium, SO4, because potassium that's group 1, the aluminium group 3, SO4 2.12H2O, and this is known as alum. So this is an example of what? A double salt. Then when we talk about complex salt, we can have copper tetraamine. Copper 2-tetraamine is an example. Copper 2-tetraamine is an example of what? Complex salt. We can also have iron, that's KFeSCN is +4. Then we have 6 of this, and here we're going to have 2+. So we're going to have this. Let's say when the cyano is now -1, then we have 6 of it. So we have 6 of it +2. That would definitely be so this is +4. This is +3. So +3 that would definitely be -3. -3. So because in this situation, if we have to calculate the oxidation number of this cyano here, we have Kc +1 +3 +6 into -1. Then will be what? That will then be 4. So it's supposed to be -2. We have a -2 charge here. These are examples of normal salts. I said normal salt, complex salt. And also, if you don't want to have it, if there's a way it can be restructured so that you might not have CN4, then this one, when your ion here is +3 charge, then this one is just a normal complex. So that is what you have for complex salts. So also relates degree of dissociation in strength of acid and bases. The strength of acid can be defined as the ionizable, that is when the ability of an acid to lose protons is definitely the strength of the acid. That is, the more the number of protons being lost, the more will be the strength of such an acid. So also relates the degree of dissociation to conductance. First and foremost, it should be noted that pKa is equals to negative logarithm of Ka. Negative logarithm of Ka. That means there will be a higher value of Ka. Then the more the value of Ka, the less will be the value of pKa. That is the relationship. Then the degree of dissociation of conductance. We know that the more the degree of dissociation, the more will be the rate of conductance. That is the rate of conduction of electricity. So that means there's a direct relationship between degree of dissociation and what? Conductance. Then perform simple calculations on pH. So we know that we should bear in mind H plus OH minus equals to what? 10 to the power -14. We should also know that pH is also negative logarithm of hydrogen ion concentration. Then lastly, we should know that pH plus pOH must be equals to 14. If you are to perform any simple calculation as far as pH is concerned, we need to have all this in mind because they are very, very important and they are interwoven. There could be some question whereby you will need to employ the 2 to solve the question. There could be some question whereby you need to employ the 3. So you need to have this at the back of your mind in order to be able to survive as far as the calculation concerning the pH is concerned, which we are going to look at in the questions centered on calculation. Then also identify the appropriate acid-base indicator, which that is the one I did earlier, where I was able to state that the color of phenolphthalein acid will definitely be what? Colorless. Then also interpret graphical representation of titration curve. So if you have to talk about graphical representation of titration curve, then we're talking about the pH with respect to the volume of the base, VB, volume of the base. We are plotting this against this, whereby at this point, let's say that is the neutral, 7, then at this point we have 14, because pH ranges from 0 to what? 14. So in that situation, let's say this is our 0 level, then we have, let's say there's a broken line somewhere here. Then we have kind of stick off this way. At this point, this is the point that is called what? The equivalence point. An equivalence point is usually what? The point at which the quantity of acid is equal to the quantity of base. Then it is steepest at this region. So what the implication? By implication, it means that phenolphthalein, the choice of pH or the choice of temperature is dependent on the steepness of the curve at any point on the titration curve. What it simply, that means the steepest part of the curve is heavily dependent on what? The titration curve. So what it simply means that before a choice of indicator can be made, we must bear in mind the steepest part of that particular curve. So in that situation, what it simply means is that phenolphthalein is used at when the steepest part is greater than or equals to what? When the steepest part, that is the pH at the steepest part, the pH at the steepest part is greater than or equals to what? 7. Then when you have the steepest part with the pH less than 7, then we talk about what? So we use methyl orange here, and here we use phenolphthalein. So that should be noted. Identify the appropriate acid base, that's what. The interpretation of graph representation, that's what I've done. Then perform simple calculations based on the mole concept. So we know that mole concept is telling us that mole is definitely equals to what? Mass over molar mass. We also know that mole can be volume of gas or gaseous molar volume. So it depends on the approach.